Okay, question 5b. Give one variable that the student should have controlled. And this relates back to question 5a, where the student investigated how the mass of water in an electric kettle affected the time taken for the water to reach boiling point. Well, the most important one here, I suppose, because they're doing it from mains electric, you could potentially say the same mains, but really the key bit is the start temperature of the water. If they put boiling hot water in to begin with, it's going to be very quick to boil, whereas they put ice cold water in, obviously it'd take much longer. So the key variable there is start temperature of the water. Be careful you don't say the same equipment here, okay? You rarely get a mark for that. The assumption is always that you're going to use the same equipment. And here, in the question you could say the same electric kettle, but the actual investigation is the mass of water in an electric kettle, so it's implied that they're going to keep that the same anyway. Figure 2 shows how the mass of water in the kettle affected the time taken for the kettle to switch off. Okay, it switches off, remember, when it gets to boiling. When it gets to boiling, that's when it switches off. That's figure 2. Time taken here. Go outside, mass of water in grams. Suggest why the line on figure 2 does not go through the origin. Okay, so why doesn't it go through the origin? It's worth 1 mark. So that's interesting. So if I put no water in it at all, it would still take, what's that, about 12.5 seconds to go before it switches off. Well, why is that? Well, because the kettle is actually measuring the temperature of not necessarily the water, it's measuring the temperature of the element. So the reason it does that is because it takes time for the kettle to heat up itself. Okay, so the kettle heats up itself. Okay, or the element heats itself. So the kettle is heating itself. So if you do shouldn't ever do it because you might break the kettle. It's not very good for kettles, I don't think. But if you put no water in the kettle, it would still take a little while to get to 100 degrees Celsius. Suggest why the results give a non-linear pattern. Okay, so non-linear means not straight. Okay, and if you look at that line there, okay, it starts to sort of curl down a little bit here, starts to bend. If we continue that line forever and ever and ever, I'm sure what it would do is it would eventually sort of curve like that. Okay, now the reason that is, well, there's a few different reasons. There's one about efficiency. I suppose you could say that efficiency, the more water there is, the more efficient it becomes, because it's going to release less energy to the surroundings. Now the key bit here is that it's going to be non-linear because energy is released to the surroundings. So energy is dissipated. It's dissipated to the surroundings. So the graph, we'd expect to get a different graph. So i.e., what I mean by that is heat kettle uses some energy to heat the surroundings. Okay, now what happens is it's dissipated surroundings, you notice that more, so there's more of an effect when there's less water. It's not a standard effect. So you're getting more energy surrounded to this, provided to the surroundings when there's less water. And you can imagine that immediately by thinking about if the kettle's almost empty, then actually there's a lump of air in there that you're also heating up as well. Whereas if it's full to the very brim, there's less air in there that you're heating up.